Hello everybody. Today's lab is going to be the flame test lab. In this lab, what we focus on is going to be to look at how electrons absorb energy and jump to different energy levels. And if you think about, say, Bohr's model of the atom, having these various energy levels, electrons are in the ground state here. But when we excite them, when we add energy to them, we cause these electrons to go from the ground state to jump up to a higher energy level to the excited state. But they're not going to stay there for a long time. They're immediately going to drop back down to where they came from. And when they drop down to the ground state, they emit energy. And the energy that they emit is going to be in the form of light. Light that we are going to be observing here through the colors of flames that we could see produced by these wood splints and a Bunsen burner. So the first thing we want to do, once we're set up with our safety equipment, we have goggles on, we have aprons on, or a lab coat, our hair is tied back, we could begin with the lab. And the first thing I'm going to do is light this burner. I have the Bunsen burner attached to a gas jet. The gas is off currently. I have my matches and I'm ready to go. What I'm going to do is I'm going to light a match first and hold it here at the base of the burner, turn on the gas and just bring the match right up into the burner flame, and we have a nice burner flame like that. Okay? And we'll dispose of the match and all of these wood splints in this metal bin that I have off to the side here. When I look at this burner flame, what I'm going to look for is the darker inner blue cone right here in the middle. That's going to be the hottest part of the burner flame, and that's where I want to put this wood splint. You can see it's right about there. Okay, that's where we're going to give the wood splint a good amount of energy to get these electrons jumping. So I'll take a wood splint out of this beaker with the crucible tongs, and notice it just looks like an ordinary soaking wood splint. But when I put it into the burner flame, that's going to be me adding energy to the electrons in the atoms, and that's going to get these electrons jumping, or that's going to get these electrons excited. Let's go ahead and watch that. And you can see, as I do that, the variety of colors that are produced from this wood splint. That is evidence that these electrons have gone from the ground state up to an excited state because we have added energy to them from the burner flame, and they have dropped back down to the ground state, emitting that energy. The colors of light that we see is evidence of the energy that is emitted when an electron goes from a higher to a lower energy level. So guys, now what we're going to begin to do, I have a whole variety of compounds here, and I'm going to begin to take wood splints out of beakers that have varying compounds in them, and we're going to burn them and look for the colors and maybe look for patterns or similarities in the colors that we see these compounds producing. Next compound is sodium carbonate, Na2CO3. Next one is potassium nitrate, KNO3. Next is lithium chloride, LiCl. Next one is strontium nitrate, SR, NO3 enclosed in parentheses, sub 2, SR NO3 2. Next one is copper 2 chloride, copper chloride or copper 2 chloride. Formula CuCl2. Next compound is barium sulfate, BaSO4. Next, we have potassium chloride, KCl. Next compound is sodium nitrate, NaNO3. Next compound is copper sulfate, or you may have heard this compound as copper 2 sulfate. Its chemical formula is CuSO4. Okay. Next compound is lithium nitrate, LiNO3. Next compound is barium chloride. Barium chloride with the formula BaCl2. Next one is strontium chloride, SrCl2. So now you have seen all of the known compounds. The last one I'm going to do for you is an unknown. But I'll tell you it's a mixture of multiple solutions. So think about all of the known compounds that I have done and think about what the colors are that you observed. And now when I do this one, you probably are going to see a combination of colors. So think about what possible combinations of elements are going to be in this one. So guys, you have seen all of the compounds and the unknown now. Things that you want to be thinking about are, what are some of the similar colors that you saw? And think about the names or the formulas of those compounds. And can you see some kind of a pattern between the elements that are in the compound and the color that you observed? And again, what we're focusing on here is also thinking about electrons moving in energy levels inside of atoms. When we apply an energy source from the burner to these atoms, we're causing electrons to jump. And when electrons jump from a higher to a lower energy level, they emit a color of light, the colors that you just observed. And you want to try to recognize a pattern between the colors that you were observing and the elements involved in these compounds. Good luck!